Take a look at this quiz review. You're going to have a quiz on 9-1, 9-2, and 9-3. 9-1 is all about a squared plus b squared equals c squared. Okay, so I give you a chance to practice a couple basic Pythagorean theorem problems. If I tell you the hypotenuse, like in this case, I'm telling you the c, so to solve for one of the legs, you must type in 16 squared minus 10 squared. Okay, so 16 squared minus 10 squared, that's going to be 156. And then we take the square root. Now, 156 is not a perfect square, so it would result in a decimal answer. So is it a Pythagorean triple? No, it's not. Pythagorean triples are integers. They're nice numbers. So what I would want you to do, though, is simplify. Reduce this radical by finding a perfect square. So you would look at my sideboard, or you just know you generate a perfect square by taking the number times itself. Okay, 64 won't fit in. 16 won't fit in. I know 4 fits in, and 4 fits in 39 times. So I'm going to rewrite this as root 4, root 39. That's still root 156, but the square root of 4 becomes a regular 2. So the best answer in radical form is to write 2 root 39. Okay, and again, if it was my rules, I would let you write decimals. Take this S calculator for the square root of 156. It would be the exact same answer as typing in 2 root 39. They're the same answer, but you want to make sure you are following the directions, simplest radical form. Okay, for this next one, we are finding c. So x is really c, so I need to ask the calculator for 9 squared plus 12 squared. Okay, we're going to see that this one will work out nice and neatly. 9 squared plus 12 squared is going to be 225. So you take the square root of 225, and that actually is a nice answer. You can see it's just a 15. So that is a Pythagorean triple. Okay, 9, 12, 15. Okay, here, this is a leg. So 14 squared minus 13 squared equals x squared. 14 squared minus 13 squared, that's going to be 27. I take the square root of 27, which can be simplified. So again, I want you to realize I want it in simplest form. It's fine to show on your paper, but I'm hoping you realize 27 is 9 times 3. And the reason we want 9 is the square root of 9 is a 3. So 3 root 3 is in simplest radical form, and it's not a Pythagorean triple because it's not a nice number. Okay, for this next part, you just have to remember, if I give you 3 sides of a right triangle, the sum, when you add any 2 of the sides, that has to be greater than the third side. So all these can be triangles except for number 5, okay? Because number 5, it's really square root of 4 is a 2. I have a side of 2 and a side of 9. That needs to be greater than this third side. Well, it turns out to be equal to it. So this one right here is not, because, again, it's supposed to be greater than, okay? The sum has to be greater. It's not, and that's the only one where it's not going to work out. So this one I can cross out, but the rest, if you take this plus this, that's going to be greater than 16. Any combination, 9 and 16 is going to be greater than this. So the rest of these are yeses, okay? So then the next thing you have to do, you need to tell if this is a right triangle, obtuse triangle, or acute. And it's based on taking the 2 shorter sides. So this root 65, you square it, you take the root 79 and square it, and see if it's equal to c squared. So in this case, when you take the square root of, or you square a square root, you're just going to be left with 65. So if I take my calculator, so I don't need to type in root 65 squared. I know it's a 65. okay? And I know this is going to be a 79, and together is a 144, and that will equal 12 squared. So the fact that they are equal to each other, we know it's a right, okay? We can skip number 5 because that's not even a triangle. So going down to number 6, I'm going to see if 8 root 3 squared plus 9 squared, see if it's equal to 16 squared. Okay, now if it's not equal, then that means it's either going to be acute or obtuse based on the scenario of the numbers. So we'll explain that once I type in 8 root 3, close the parentheses, square it. Now, if you don't want to do that, you square the 8 times 3. So you're squaring each of these factors, but I have it typed into my calculator correctly, plus 9 squared. That side is 273. And I'm going to compare it to 16 squared, and that's only a 256. So this is less than. So my c squared is less than. That means it has to be an acute triangle. That means all 3 angles are less than 90. Okay? So then this next one, it's going to be root 7 squared, which is just a 7, root 7 squared, and it's going to be 14 squared. So I get 7 plus 7, that's going to equal 14. 14 equals 14, which means it's a right angle. Okay? And then the last one, 9 squared plus 3 root 3 squared, does that equal 14 squared? So again, I'll use my calculator. 9 squared is 81. I'll just type it in as 9 squared, and then parentheses, 3 root 3, push away, close the parentheses, square it. You're going to see that that's 108. So we get 108 on this side. 14 squared is 196. This is bigger. So c squared is bigger. That makes it obtuse. So if c squared is equal, it's right. If c squared is less, it's acute. If c squared is larger than the number, it's going to be obtuse. So that's the scenarios to be able to tell what type of triangle we have. Okay, hopefully that makes sense. Okay, question 9. This is where we have a right triangle and we create an altitude, which then creates 3 similar triangles. So I have my ABC, that's the big triangle, and I need you to know that the middle, this is my 90-degree angle. So 90 degrees, we want to match up the 90-degree angles. So let's do the small. So the small is A, B, P, and P is my 90-degree angle. Okay, I need you to know for this small triangle right here, P is my 90 degree. I'm going to put P in the middle. Okay, and I need you to know the big and the small, they share angle A. Okay, so this has to be angle APB, which means C and B must be the same measurement. Okay, they all have, all the corresponding angles have to be congruent. So this is the small. Now let's compare the medium or middle size. Okay, so once again, my P, this one right here, so this triangle right here, the 90-degree angle is P. This time though, we share C. So C must match up with C, and then that only leaves the letter B. Okay, so this angle and angle B right here have to be the same measurement. Okay, so that's what you must do. So if I give you a problem like this where I take a triangle and I create an altitude, you are going to have the big is similar to the small, the big is similar to the medium, the small and medium are similar, they all match up. All the corresponding angles must be the same. Okay? This next problem, you are going to find the geometric mean. It is super easy. All you have to do is multiply 8 and 56. You take the product. So let me grab my calculator. It's 8 times 56. I'm going to get a 448. Okay. And then it is our job to clean this up. Now, again, I will give you majority of the points if I see the square root of 448. It's not a perfect square, it's a decimal. If I take the square root of that, it's an ugly decimal. So then what we need to do is take a couple moments and try to find and simplify. Find the largest perfect square that fits in. So with 448, it's a bigger number. I can try 144. 144 is 12 times 12, and you're going to see it doesn't fit evenly. Okay, so this may take a moment. You look at my sideboard and you start dividing by perfect squares. I'll try 81. Okay, you want the largest, it doesn't fit. So then I know 64 will fit in. Okay, 64 fits in 7 times. I'm going to break it down. 448, the square root of 448 is really square root of 64 times the square root of 7. Can't argue that. 64 times 7 is the same value. But then I can write 8 root 7. The square root of 64, if you don't know that, you should know it, but it's a nice 8. And then root 7 stays root 7. That's how you simplify. You did that in Algebra 1. That's how you simplify a radical. Okay? Then this next part is based on our 9.3. So 9.3, you can see here, I'm dealing with the altitude. I don't know the altitude. I want to find the altitude. So what I can basically do is square the altitude and then multiply 64 times 36. And then I take the square root of that. So now, just to save some time, I'm actually going to multiply. I'm just going to take the square root of each because these happen to be perfect squares. So x is going to be 8 times 6, which is going to be a 48. Okay. Now, if you say you didn't recognize that and you took 64 times 36, you're going to get 2,304. But watch this. If I take the square root of that answer, I get a 48. Okay. So x is 48. Okay. For number 12, I am not dealing with the altitude. I'm dealing with this side. I want to know this side. So this side needs to be squared. Okay. Then I need to know what this is. Okay. This side of this. Well, they told me the whole thing, the whole base is 25. So 25 minus 16, it forces that piece to be 9. Okay. So just label this 9. Okay, this piece is 9, that's 16. I multiply 9 times 25. Okay, and then to solve for x, I take the square root. And once again, both of these are perfect squares. So 3 times 5, I know it's going to be 15. Okay, but again, if you took 9 times 25, you get 225, and the square root of that answer is going to be a 15. So again, if you can look for little shortcuts, it can save you some time when it comes to simplifying. So let me write my 48 here and write a 15 here. Okay. Question number 13. Once again, I am dealing with a side. Okay. Nothing to do with the altitude. So I take my side and I square it. That's going to equal 6 times the overall length, which they don't tell us. They tell it's an x, but it's real easy to solve. Okay, so all I need to do is square the 14. I get 196, and then divide by 6. So I divide by 6. It's going to be a decimal. It's going to be 32.6 repeating. Okay, that's all I need to see. If you round to 7, I'm fine. 32.7. That's fine as well, or 32 2/3. So 32 2/3 is also an equivalent answer. Okay, so then for 14, I'm back to knowing the altitude. I take 9 squared, the altitude, I square it, and that's going to equal, when I multiply these two things together, two bases here, it's just a 3x. This is 81. I divide by 3, And you're going to see 81 divided by 3 is a nice 27. Okay, so hopefully that is easy once you do enough of these type of problems. That is our notes in 9.3. Okay, relations within a right triangle when you're dealing with an altitude. Okay, so hopefully that makes sense. For number 15, you can just use the Pythagorean theorem. I'll also show you another way, but they tell us this ladder that's leaning against this building is the base is 6 feet away. So from the bottom of this to where the ladder is extended from is 6 feet. Okay, so that again is just the Pythagorean theorem where I take the hypotenuse, square it, minus the leg squared, and it's going to equal how high this is. So we're really trying to find this. Okay, we're trying to find that opposite side here. So I'll call it b squared. Doesn't matter which letter I use, A or B. But if you take your calculator, 12 squared minus 6 squared is going to be 108. Okay, and they tell us around to the nearest tenth. So I'm actually going to ask the calculator for the square root of 108, and it's going to be about 10.4. Okay, now another way you could have got this. Okay, I just want to show you this. The fact that they don't tell us this angle, but I know angle X is 30 because look at the hypotenuse and look at this side right here. They're half of each other. So the fact that we have 12 and we have exactly half of 12 is 6, I know this must be 30 degrees. Okay, so the short side, actually this is 30. This will be 60. So my bigger side is going to be 60. But to find that larger side, I can take my short side, which is half the 12, and multiply it by root 3. Okay, so just to show you this on the calculator, 6 root 3, I would stick with the Pythagorean theorem, but this happens to be a special right triangle as well. Okay, so if you could recognize that this was a 30-60 based on the hypotenuse and the short side is half the hypotenuse, you could have, instead of using the Pythagorean theorem, take 6 root 3 and get the same answer. Okay, so then the last part of this is all about the special right triangles. There's only 2 types of special right triangles. It's either a 30-60 or a 45-45. Okay, so this one, I start with hypotenuse. I need you to know that the short side, the shorter leg is half. So y is a 4. Okay, and then once I know the short side, to find the longer side, I just take the short side times root 3. Okay, and you can just leave it in that form. I want it in simplest radical form, so I don't want decimals. Okay, so then for this one, it's 45-45. If this is 9, it forces y to be 9. Both legs have to be the same. And then the hypotenuse, the bigger side, is going to be my leg times root 2. So just leave it in that form. Okay, no decimals necessary. Okay, so then for 18, I am telling you the short side. So if you double, now you say, how do you double 3 root 3? You just double the regular number. It's 6 root 3. So m is 6 root 3. Then n, this side right here, is the small times root 3. Okay, so 3 root 3 times root 3. This becomes root 9. So you still have this regular 3 times the square root of 9. It becomes 3 times 3 because the square root of 9 is a 3. That just gives you a 9. So side n is a 9. Okay, so again, it's your job to understand when you're going to multiply by root 3, when you're going to divide by root 3, and when you're going to double your number. Okay, that's the relationship. We have that up on the sideboard when you take your quiz. Okay, so then the next one, don't be confused by a side that's root 6. Once again, that's the shorter side. That's the side opposite the 30 degree. I know if that's 60, that forces this to be 30. So I have the small side. I can double it. So x is the hypotenuse, I can put a 2 in front of it. That's what x is. X is 2 root 6. And then to find y, I must take root 6 times root 3, which is root 18. Okay, but then I would want you to simplify it as 9 times 2. Within 18, there's a perfect square, and it's a 9. Final answer is 3 root 2. Okay, so that is the best answer for number 19. Okay, so just, again, it's your job to make sure you know, at least know, okay, whatever this number is, I'm doubling it to find the hypotenuse. Yes, it's an ugly root 6, but 2 times root 6 is how you double it. And then root 6 times root 3, you can at least get a root 18. And then I'm hoping that if it can be simplified, hopefully you know your basic perfect squares, how you can break up 18 is 9 times 2. 9 is a perfect square. So force yourself to understand where these numbers are coming from. Okay? So now here is where we will need to divide. Okay? I am finding legs. Both x and y are the same, so x equals y. So it's our job to take 8 and divide it by root 2. And I would want you to clean it up. So you multiply both top and bottom by root 2. You have 8 root 2 up top. You have, this becomes a regular 2. It's root 4, but the square root of 4 is a 2. And you're going to end up reducing and getting 4 root. 2 fits in the 8 4 times. So 4 root 2 is the final answer. And both legs, x and y, are the same. They're both the same because they're both 45-degree angles. Okay? And then finally, this last one, I tell you the hypotenuse. Okay? So give you the hypotenuse. To find the shorter side, the side opposite to 30, I just take half of this. So half of 8 is 4, and then just keep the 5, root 5. So y is 4 root 5. And then the short side to bigger side, I multiply by root 3. So I'll show this down here. I take 4 root 5 times root 3. Keep the regular 4. Can't do anything with that regular. There's no other regular numbers to multiply. But root 5 root 3 is root 15. And we're finished. Okay, so x, the best answer is 4 times the square root of 15. Okay, so that is everything you need to know. Okay, I need you to force yourself. Again, you should know when, if it's a 30-60, are you doubling the number? If it's a short side, I have to double it to find the hypotenuse. If I have the short side, I want to find the long, I multiply. No matter what the number is, I multiply that number by root 3. Okay, so we need to be able to keep this stuff straight, and hopefully we can end with a 9-1 to 9-3 quiz where everybody does very well on. So if you can do these problems, you can't help but do well on the assessment. So thank you for watching. That takes care of our 9-1 to 9-3 review.